In this short video, we're going to talk about standard deviation, or more specifically, I'm going to show you how to calculate a standard deviation. It's a very straightforward process, so nothing really too demanding in this, hence it's quite a short video as well. But it is very important. It's important to be able to calculate standard deviations because they are constantly spoken of in statistics, and they're such a useful statistic also. It's very straightforward to calculate one, but it's the interpretation of standard deviation is sometimes confusing for students. Well, these will be dealt with in other videos. In this video, we're just going to entirely focus on the calculation, how to do one. And I'm going to start by looking at just a simple set of figures. Say here we have a variable x, and we have different, if you like, observations about this, or different measures associated with it. So we got 5, 7, 8, 2, 11, and 3. Whatever these mean, it doesn't really matter to us, but it could be weights of something, or measurements of something, or whatever it is. It could be in centimeters, the measurement of some object. But whatever it is, it doesn't matter. We've just got a set of numbers here, and we want to work out the standard deviation. So first of all, we could add it up, and we get 36. And that's quite useful because we're going to need that figure. Now, to calculate the mean, we simply take sigma xi, so we take each observation is known as xi, because it's a particular observation. The sigma means the sum of, so we add up each one. So we add up the sum of x1 plus x2 plus x3 and so on until we get up to, in our case, 36. And then we divide it by the number of observations, or the number of instances that we're counting. So we divide it by n. In other words, we take 36 and divide it by 6, which is equal to 6. So the average, or the mean, is 36. Is 6. It's 36 divided by 6, which is equal to 6. Now if we write the means down in the next column, so for each one we have the mean. Now we're writing it against the original value. The original value in the table here was, let's say, 5. We write down the mean was calculated to be 6. The next one is the value was 7, but the mean was 6. The value was 8, the mean was 6. So just write it down as I've done there. Now if I take the mean away from the original value, if I do that, we're going to get 5 minus 6, which is equal to minus 1. We've got 7 minus 6, which is equal to 1, and then so on. 8 minus 6 is equal to 2, 2 minus 6 is equal to minus 4, 11 minus 6 is equal to 5, 3 minus 6 is equal to minus 3. Now, if we add that up, it comes to 0. It'll always come to 0, because the mean is the central measure. Everything is around the mean. So what's higher and what's lower must balance. They must add up to 0. So that doesn't get us very far. What we need to do is we need to get rid of the minus signs. And if you like, the trick here, or the way to do that, is just simply square it. So if we square it, we're going to get minus 1 times minus 1, which is 1. 1 times 1 is 1. 2 times 2 is 4. Minus 4 times minus 4 is 16. So the minus signs have gone. Now if we add that up, we get to 56. Without squaring it, we're always going to get a 0, so that's not of any use to us. But when we square it, we get 56. That's useful. Now the standard deviation is equal to the sum, it's equal to sigma, the sum of each x minus the mean squared, all divided by the number in the set, the number of, if you like, observations if it's a sample, but the number that's in the set. So in this particular set we've got 6, so n would be equal to 6. So standard deviation is simply 56 divided by 6, which is 9.33. Now the interpretation of this, as I said, I'm not going to deal with because it's dealt with in other videos on the course, and I suggest you look those up and we'll figure out how to use this. But it is a very important calculation. It's one you should be able to do. If we do it for a population, we call it the standard deviation. We do it for a sample, we call it the standard error. But it is the same calculation in a sense. It's done in the same way, but it's a very important calculation in statistics. So that's all I'm going to deal with here. That's how to calculate a standard deviation, and that's all I'm going to do. So let's leave it at that and say thank you for watching.